Good morning, Barada, Sirachi. I'd like to thank the UK Passive House Conference for asking me to speak here today. Can you hear me at the back? It's okay. I once heard a speaker say that at a conference, to which the reply came, yes, but I'm willing to change places with someone who can't. Hopefully it's of interest. Some great introductions so far. Hopefully we'll put it into context with our experience. Carnarvon Hedgan, the UK's first certified passive house offices, begun a design process in 2007, completed in 2008. So basically we've had a couple of good winters now and summers to test this building, going into our third winter. Why did we take a passive house approach? Well, coming back to Jonathan's comments before, we chased energy reduction first. And as our first meeting with the client, we wanted to stress that straight away. We're going for energy reduction. Let's put the carbon question to the side. As soon as that penny dropped, we felt we had a project. The client understood exactly what we wanted to achieve, and it was within their within their remit. So, I suppose we'll get it over and done with. Do you want the good news or the bad news? Did it work? Well, basically, it didn't achieve the design targets for space heating and primary energy. It beat them. It did better. So we can probably all go to the pub now, because I know our design team definitely did with the client when the results came in. Monitoring. How much information do we collect and what do we do with it? We come back to certified products. We use certified ventilation systems, windows, as much as we could, our first project to make it work. So were we going to test on site that those products performed efficiencies, G values, as predicted, as on the Passive House certificate, connected with the software? But then it's a field situation, so there will be slight variation. So was that worthwhile? Do we check it against our design and compliance tools? For us, crucial. We really wanted to see, can we use this design tool and trust it in the future? Does it work for us? We could create a massive body of raw data, measure everything for everybody then to sort of analyze, but it costs a lot, and sometimes I think it stops you looking at the individual building and the circumstances. Specific client inquiry. They wanted complicated made simple. This was a test case for a lot further buildings, which will happen in Powers. They wanted to test it. If it worked, they need to present simple questions of cost, performance, and buildability. And now we're getting recognized formats, retrofit for the future competition, TM22, probe, etc. There's a lot of different ways to measure a building. Occupant perception, maintenance, they have very different views, and they're usually not involved in the process, are they? It's good to involve them right at the start. So here's our driver project. What did Powers want to do? They wanted to reduce their CO2. Essentially, they wanted to test this mantra. Could we use less energy and give more comfort? Well, cost-wise, we did well. Basic building, 1537. Essentially, we delivered the Passive House fabric for the same price as a normal building reg school. We're working to 2006 at this time. So the fear was the big leap to Passive House costs was going to be quite a large margin. We maybe think it's less now, but we hit that target. So it was a good start for the client. Obviously, Nick and Richard are going to talk more about this later, how we reduce this graph. Now, we put our neck on the line a bit. This is before the retrofit for the future emphasis was coming out. We were trying to say insulation and airtightness is a technology. Do we call insulation a technology? We always seem to rush down the bottom here and call these technologies. We're saying insulation, airtightness is a technology, and it doesn't break. It just sits there doing its job. So we put our neck on the line and said, would the fabric-first approach work? And hopefully we've got data which can inform the fabric efficiency standard debate now. That was our brief. Maximise revenue through the design and management. They're the architectural issues, but reduce energy consumption, fuel bills and overheads. It's part of local authorities' economic models. Is this a no-brainer? And by the way, Passive House certification and BREEAM. So there we were. We had to work with a range of BREEAM principles. So there's a compliance. The compliance in this case is we had to get BREEAM Excellent to get the grant from the Welsh Assembly Government. It was a bit of an aside. It was a reduction in energy, which the client really wanted. And we looked at specific data. This was our biggest concern. What was the weather going to do? We were in so early, there wasn't any data sets, wasn't any other research. So we worked with the PHI, using the meteor norm to monitor specific data for that. We'd already used some of this data for our other project and the residential passive house of oil up the road. So we were fairly confident it was working. And this was the outcoming project. External timber frame, internal masonry core. You can see standard passive house principles, large glazing to the south, reduced to the north. Interior picture, so a normal looking office, training centre, and there's one of the rooms where we did specific experiments in. So again, were we going to test in detail whether centralised or decentralised ventilation worked? Were we going to test the electrical efficiency that we tried to build into the project? Well, here are the end results after 2 years monitoring. So we believe that the second winter more because it was dried out. The most coldest winter in Wales for 30 years. So essentially, there was our design. These were the figures we broke up for the CIBC Design Awards. Our target was 15, and it actually achieved 14.8. Here's the interesting one. We were slightly over in operational energy because a server came in very late. But our operational energy was actually a lot less than predicted. So as a prediction tool, design tool, we're very pleased with PHPP 2007. The question was, we went to great detailed lengths to very specifically simulate all the IT that would be in the building. They've since taken that server out of the building 3 months ago and moved it to the local GPO office. So is this building robust enough to still cope with large changes in specific internal gains? So this is what the client wants to know. Do we have to completely redesign the building now that use has changed? Or will it still work? So this is our next phase. And I think it's interesting. The first buildings are now starting to change. And these buildings will change. Occupants will move in and out. But here's an interesting one for us. Building regs, part 2, predicted 46. It actually ran in at 12.7. So what we're saying here is the compliance tool was quite far out. It was seriously over-predicting. However, we used TAS. Here's the interesting bit, TAS simulation. The actual real data was very much the same as PHPP, but when you add the processing for the Part L compliance, the algorithms, it starts to move really far away. So we felt you could use TAS as a design tool up to that point, but the compliance bit afterwards for the carbon, as the client understood, put it to one side because it's not useful in terms of designing and predicting the energy consumption of the building. So we felt, yeah, the PHPP 2007, it worked for us. The TAS worked. When we moved into compliance, the two things come apart. We'll have a look at some of these charts. We started chasing individual energy use, looking at different appliances which had big differences between working and standby levels. Now the next one is a big interest for us. That was our standby, building base load, trying to reduce, always reduce. Now, huge server energy consumption, external lights, very interesting client decision. We wanted some very energy efficient ones. No, they wanted very robust ones for vandalism, really heavy on consumption, but very reliable. And these are the sort of decisions we have to take. We pushed the client so far on the project, at certain points they had to feel they wanted to recoil. They didn't want an unsuccessful project just because the windows got broke, because that's what everybody sees around. It's strange how we measure the success of buildings. So we did some detailed experiments in a couple of particular classrooms. But I like to say this shot. When you walk into a building, what are you expecting? Well, this is one in Manchester. It's not my favourite haunt, but in terms of energy efficiency, I mean, they're not even useful. You can't even light your cigarette from these things burning gas 24/7 outside. But what do you go in there? What are you expecting from that place? Well, probably a lot of comfort after a couple of hours. So we turned our experiments into graphs like this, but that doesn't mean anything to our occupants. They just want to work, use the building. They want complicated, meet simple. Was it comfort? And their perception was quite different to our measurements. Here we charged a room full of 24 people and looked what was happening. There's our baseline CO2. There's our 1500, which Justin was talking about, legal limit for schools. Normally it's much higher than this, much higher. We stayed within the CO2 levels. Our humidity was a little bit low. We've tuned it now, and we are in the theoretical comfort zone of 40 to 60%. That's what all the books say. However, people walking into the building say, to be honest, it's a little bit dry in here. Yeah, but by all studies, since they've been made, you're in the comfort zone. Interesting. Mid-Wales, outside in their ventilated homes, naturally ventilated, it's 90% humidity most of the year round. We're near the sea. That's what they're used to living in. So they walk into a building at 50% in the theoretical comfort zone. We've hit all our targets, but perceives a little bit dry. So these little sort of interesting issues started cropping up when people who weren't aware of all the technology. What was their instant response to the comfort levels? In terms of light, in terms of thermal comfort, very, very good. But the humidity is still an issue we've got to deal with, I think, because we are in a damper climate. Again, second experiments. I think we can discuss these if anyone wants in more detail afterwards, but I'm just trying to get the principle that some unexpected results came out of this. Here's our filters. This is where you start to show these to the occupants. They don't understand all the data, CO2 levels, but you show them this, you would be breathing that in if we weren't filtering it. Immediately, that's their definition of air quality, not parts per million. Feels warm, but that's why we have a filtered system. Here was another very practical issue about installing. Our M&E contractor just did not believe that the building would use this low amount of energy. They would refuse to fit the smaller boiler that we wanted to. Okay, we'll run with it. As a result, of course, the ignition board broke twice because it kept cycling. It couldn't modulate low enough. So we've since fixed that, and we're monitoring the efficiencies and the outputs and we've taken it on board. But we chose a boiler range that was on Powys County Council's standard maintenance team, so all their plumbers knew it. So they knew the boiler, they just didn't know the building concept. Now they understand it. I think we can probably have a very low maintenance boiler system. One pump in this house, one gas boiler. We weren't chasing carbon complex systems. We just wanted to keep it simple and robust. So although a little problem, we hopefully we proved a point. 4 seasons in one day. Well, automatic summer bypasses, changeovers. Again, it's back to how robust are these buildings? Are they very precise? If you bring a group of 20 people in for a tour, is there a big problem? Do ventilation systems move rapidly and adapt? We found actually it is fairly robust. There is a lot of latitude within these buildings. It's not this, we spend so much time certifying, using PHPP, calculating and worrying about what happens if someone opens a window. I think there's a lot of latitude in them from our experience. I think maybe we're worrying a little bit too much. Very interesting to see the work on the weather data that the Scottish Passive House Institute has done and Rob has done since. Either or, we think it's both. When we first started this project, we were thinking all we're going to get is cloudy skies with higher temperatures. That's the weather model we're going to be working on. Got hit by incredible weather, real continental weather. -17 we had outside at one point. And then huge solar gain. I think they work with both the weather models. They are designed to do that. So whether we're getting cold weather and good sunshine or cloudy and higher temperatures, the building still performed. Again, a bit more robustness, a bit of an interesting, pleasant surprise. The results from all this monitoring, which was commissioned by Powys County Council, we put together for the SIBSI Awards. It's nice to have recognition of the work, but I think the biggest point for us and for the Passive House community wide was this is the first award we're aware of in the UK of, it's actually for 2 years after the building has been built and monitored, not at the beginning. It's actually a comparison of predicted and actual energy consumption. First time this award has been given, and of course, not saying that SIBSI advocate or support the Passive House concept, but we're really pleased that they've recognised it, and we feel this will be good for everybody working in the industry, that a fabric-first approach did work, reducing energy consumption first. Here again, this was our initial EPC ratings from compliance, but when you actually look at the actual energy consumption, real, it comes in an A straight away on the building because it uses a lot less than the compliance tool predicted. So in reality, it's an A, it's nearly an A plus before the PV goes on. If you look at actual consumption rather than the compliance section added on to actual predicted consumption. Here's the bit the client liked. £126 a year it costs for gas in the coldest winter on record in Wales. Electricity, there was a grant, it was Clear Skies too, but essentially if we had fit income, the fit income would actually pay for for all the bills. So it goes on from what Lynn was saying, that the renewables don't only pay for themselves with a fit, they actually pay for the rest of the building's energy consumption. What were our biggest lessons? Well, okay, duplication of design costs. This is a big issue. Can we just stay with PHPP and comply? That would save us a lot of additional time working through the additional software and additional compliances. This was a big wrestle, technically, trying to comply with the minutiae of UK building regs in conflict with the passive house concept. A lot of bargains were struck, a lot of risks were taken, but hopefully that it's worked can go out for peer review and we can put this data out for other people working in similar situations. But this was a huge one. Powys County Council will now write usable building trust soft landings into any project. It's in contracts now. They see the value of analysing every building that they build in the future and building that knowledge. There's no more hit and run in Powys, looking for long-term relationships, which is great. So we managed to hit the thermal targets, keep it warm in summer. Did we stay cool? Here was our summer cooling strategy. I'll show you this one in particular because here we are, midnight, 18 degrees in Machynlleth in summer. We're lucky normally to get that during the day, actually. We're doing pretty well. But it comes back to the weather data analysis. We are heading for that double whammy. We've had the hottest summers and the coldest winters on record the last 2 years in a run. High air conditioning loads, high heating loads. And luckily, here we are, pulling in 18 degrees, in at midnight, 26 degrees coming out of the building, out of the ventilation units. By the next morning, we've dragged it down to 16. So we're pleased that we've managed to keep the comfort levels. 4 seasons in one day, the crossover seasons, can be a bit tricky. We are trying to rationalise that. So, all in all, we built this project, kept our head down for a few years before we rushed in on anything bigger. Pleased that it's working well. Hopefully it's useful data for everyone else. And we'd like to thank in particular Berthold, who I know is in the audience here, and Zeno Bastian. Great support from the Passive House Institute. Now, it's great to see we've got a much bigger support network around us all to try and push forward as we deliver at scale and more complicated buildings. Thank you.